In this video, we're going over the word problems page, which is page 3 in your review packet. So we're going to do a lot of highlighting in this problem so that we can stay nice and organized. This problem tells us that John had $40 in his wallet. We're going to highlight that. He went to the fair and he paid $15 for a bracelet that would allow him to ride an unlimited number of rides. However, it cost $2 for each game that he played in the arcade. So we're going to highlight $2 for each game. If John played as many games as he could afford, how much money did he have left? So we are going to first set up an equation for this to figure out how many games he was able to play if he only had $40. So we're going to set 40 equal to, so he paid $15 for a bracelet. So we know he spent 15, but he also spent some money, $2 for each game. We're going to call each game X. So he spent $2 per game, which is represented as 2X. So I'm going to do a little bit of highlighting here. So my 40 is his total, 15 is how much he spent for his bracelet, and then he spent $2 for each game that he played. So we're trying to solve for X right now. So this is a two-step problem. First, you would subtract the 15 from both sides. That cancels. It leaves you with 25 equals 2X. And then divide by 2 on both sides, and you get that X is equal to 12.5. So he can't play half of a game, but through that we know that he played 12 games. So he was able to play 12 games. So if you want to know how much money he had left over, which is what they're asking for, how much money did he have left, we're going to plug 12 in for X and find out how much he paid to play 12 games and then subtract that from 40. So we would do 15 plus 2 times 12, and you get 15 plus 24, which is 39. So we know he spent $39, so how much money did he have left? We're going to say, what was his name? John. John had $1 left, because if he spent 39 but he had 40, that means he only had $1 left. On to the next problem. So it says Ian is borrowing $1,000 from his parents to buy a computer notebook. So let's start highlighting. So Ian is borrowing $1,000. He plans to pay them back at a rate of $60 per month. Highlight. Ken is borrowing $600 from his parents, and he's planning to purchase a snowboard. He plans to pay his parents back at a rate of $20 per month. Write an equation that can be used to determine after how many months the boys will owe the same amount. That is your keyword right there. Same amount means you're going to be setting them equal. So we can set up Ian as borrowing $1,000. And if he's paying his parents back at $60 per month, we're going to call the months M. Let's write that down over here. The months equal M. So if he's paying his parents back at $60 per month, that would be 1,000 minus 60 every month. And we would set that equal to Ken, who's borrowing $600 to buy his snowboard and paying his parents back at $20 every month. So this part says determine algebraically and state how many months the two boys will have the same amount. So will owe the same amount. So that means that we're solving for the months. So we're going to copy over our equation, 1000 minus 60m equals 600 minus 20m, and solve for m. So this is, you can bring the variables to either side, but we're going to try to keep the x, or the m I should say, positive. So I'm going to bring the 60m over to the left. It'll cancel. You left with 1000 equals 600 plus 40m, and then minus 600 minus 600. Okay, I'm running out of room, so I'm going to write it over here. So 1000 minus 600 is 400 equals 40m. And then if I want to solve for m, I would divide by 40. 40's cancel, and I'm left with m equals 10. So that means that it would take them 10 months to owe the same amount to their parents. Make sure that you label, especially when it's a word problem. It's 10 months. And that's your final answer for this one. For number 3, it says find 3 consecutive odd integers. Consecutive odd integers such that the sum is equal to 45. So we're going to do let statements. We're going to let the first integer equal x, and odd numbers are always 2 numbers apart, right? So we have, let's say 3 plus 2 is 5. So the next integer is going to be x plus 2. And then the next integer is going to be x plus 4. So you have to know that sum means to add. So you would add all of those together. So x plus 2 plus x plus 4 is equal to 45. When you combine like terms, you would add all of your x's and all of your whole numbers, and that leaves you with 3x plus 6 equals 45. Subtract 6 from both sides. You get 3x equals 39, and then divide by 3. And x is equal to 13. Okay, so just take note, they want you to find all 3 consecutive integers. So if x is equal to 13, then x plus 2, which is the second odd integer, is 15. And x plus 3, which is x plus 4, which is the third odd integer, is 17. So this would be your final answer. Sorry, this would be your final answer.